Okay, hi everyone. Today we're going to solve 974 LeetCode subarray sums divisible by k. So in this problem, we are given an array nums and an integer k. We need to return the non-empty subarrays that have a sum divisible by k. Okay, so non-empty is important and thus their sum has to be divisible by k. So a subarray is we know that. Now let's see how to solve this problem. Like intuitively I had the best approach, so I'll be discussing that. If there's any brute force, because I haven't looked at the solution section till now, and if there is any brute force approach or anything other like that, then please do let me know. I will try to cover them up. So you have this array that is 4 5 0 -2 -3 and 1. Okay, and the k value that is given to you is 5. Now, so let's iterate over these arrays. So now we are pointing at this element. The sum of these array is going to be 4. So if it is 4, what is the remainder? Remainder is going to be 4 as well, because 4 divided by 4 modulus 5 is going to be 4. And so there's one important thing to observe. So how many can be there? So if we are starting with this element, yes, so now we have this remainder, right? This is the remainder 4 and the sum is 4 as well. So I will use another data structure, linear data structure, to keep a track of the count of the remainders that we are having. So for example, we have 0. The remainders could be 0, 1, 2, 3 and 4, right? And in this case, if it is 0, then this is the count basically of remainders. And then I will say the subarray sum, the number of subarrays, is initialized with 1. Why? Because if any subarray has a sum 0, then it's by default it will be divisible by k, right? Because if k divisible by any number, let's say a divisible by 5, it gives you 0, then means a is divisible by 5, isn't it? So after observing this, I will say that I will initialize everything with 0, with 1, and then after initial I will initialize 0th remainder with 1, because by default it will provide a subarray. Other than that, everything will be initialized with 0. Why is it so? Because if I find let's say a subarray with sum and the remainder of that sum is 2, it's not going to give me anything, right? It's not going to give me anything. But if I find it, but I will be incrementing it, insinuating that if I find any remainder, if I find again, for example, I've on the, let's say on ith iteration, I find a subarray that has the sum, the remainder, basically remainder of its sum value is equal to 2. Fine. At this point I will say that there is no, because 2 is not divisible by k, so my the subarray count, the answer value will remain 0, right? But after I plus, so let's say after I plus x iteration, subarray sum is again equal to 2. In that case the remainder will be same, that is 2. And if the remainder is same, now there's one thing to notice, that you have already encountered this same remainder, that is 2, but you have again encountered a remainder, the same remainder again, which means the elements that are added, the subarray that is added, the subarray after involvement of the ith element is divisible by k. And why is it so? Because if a plus b divisible by k, then this can also be written as a modulus k plus b modulus k. Which means if so if this thing is divisible by k, then it means if b is divisible by k, so b will be equal to something that is 5 of 5x, right? Because k is 5. And if this is divisible by this, will give you 0, which means a plus a divisible by k, a modulus k is divisible, right? I think this makes sense, because if you will try to think about it, This is an easy concept because even for myself I didn't went through this explanation, proving this to myself, because it was very obvious for me, and I think it will be same for you. But if it is not, then you can obviously comment down below, and I will try to help you out. So yeah, so this is the case. And now so I think now it's clear why everything is initialized with 0 except 0 remainder, and we are incrementing the array and adding them, right? Now we are at 4, now we are at 5. Okay, so at 4 what you will observe, that remainder is 4. So at 4 you will observe that the remainder is 4, and there is no subarray that will give you the answer, right? There is no subarray that will give you the answer. So your answer will be equal to 0. At second element, that is 5, at this point the sum is equal to 9, remainder is equal to 4 again. And if the remainder is 4 again, then it means there are subarrays that are divisible by k. So we can count them. And how we can count them? By taking the look at the previous subarray. And at 4, so for this case, at 4 we have this one remainder, and we will be initializing it. And now at this point we will be using it. So I will say 5 is one of that subarray that will give me the answer, and answer is equal to remainder plus this value, and that is 1. And this value will now be incremented because there are two subarrays that have 4 remainder, right? One is 4 5 and the other is 4. Now let's move to the another element. So at sum is equal to, at this element the sum value will be again 9, and remainder is equal to 4 again, and the values, and now the answer will be equal to 2 plus 1, or 1 plus the new added 2. And why have we added 2 from this side? And this is equal to 3. Now you must be wondering, how do we have two subarrays? Because I have added 2 here, right? So there are two subarrays. Let's find out. So first we have 5 comma 0, then you have only 0. So these are the two subarrays. Let's move to the other element, that is 4. Now sum value is equal to this one. So 9 minus 2, that is 7, and remainder value will be equal to, so 7, that is 2. And at 2 place actually we don't have anything. Let me just erase it to 0. Yes, now at this point answer value will be equal to 0, added with 0, because we had 1 plus 2 plus 0. Okay, and this will be incremented. And why it is added with 0? Because at this point you can see that there are no subarrays with the involvement of obviously minus 2 that will give you the answer. So minus 2 0, not an answer. Minus 2 minus 5, not an answer. Minus 2 minus 4, not an answer. So this will not give you the answer, and you are adding 0. Now at fifth case, where you are including 3, sum value is 4 again, and remainder is equal to 4. At 4 you have 3 again, so answer is equal to 1 plus 2 plus 0 plus 3. And why there are 3 subarrays? That means there are 3 subarrays, and by the way we have to increment this, and this means that there are 3 subarrays. Let's find out. So the subarrays are minus 2, minus 3, fine. Then you have 0, minus 2, minus 3. Okay, and at last all of these elements, no, not actually all of these, this array. So that will be 5 0 minus 2 and minus 3. These are those 3 subarrays. And the sixth, we have sum is equal to, at sixth element we are adding 1, so sum is equal to 5, and remainder is equal to 0. And if it is equal to 0, that means we have got the array, and which means the whole array will be divisible. So sum of the whole array will be divisible by k, that is 5. So that means the answer value will now be equal to 1 plus 2 plus 0 plus 3 plus 1, and if you add them up, then this value will be equal to 7. And is that our answer? Yes, that is our answer, 7. Now let's code it up. So By the way, there is one condition that you need to take care of. So if you encounter, let's say, negative elements, if you encounter, let's say, negative elements minus 3, yeah, minus 3. So minus 3 divisible by 3. So, or let's say minus 3 divisible by 2. So that is very much like 3 divisible by 2, and then minus 1 is multiplied. So 3 divisible by 2 is 1, and this is equal to minus 1. And we need to take care of this, right? And how we can take care of this? So minus 1 is now added with the k, that is 2, and this will be equal to 1. And this will be equal to 1. That is what we needed. And we can do this for every remainder that gives us the negative value. So first of all, we need some value. So first is int sum initialize with 0. Then we need a remainder. Well, it doesn't need to be initialized with anything. Let's just be remainder. And then we need a vector of int that is going to be something to track the remainder track, and this is initialized with k value. So there are k places in it, and remainder track of 0th value is initialized with minus 1. And I think that's it. Now we can start our implementation. So I is equal to 0. So let's say num and nums, we are iterating over every character of nums. And yes, so now sum value is added with num, and remainder is equal to sum modulus of k. So if remainder value is less than 0, then remainder is plus equal to k in order to fix the negative remainder thing. And yes, now we have main thing, and that is to add them into our answer. Let this be answer. Answer is equal to 0, initialize with 0 value, and answer plus equal to remainder track of this remainder plus equal plus plus. And why I'm doing this postfix operation? Because we need to add the we need to add the the previous value, and then add the value with 1, increment the value. So let's see if this will work. Okay, test cases are passed. Okay, it does work, and it is perform quite good. I think not idealistically good, but yeah, it's fine. And memory is also good. So yeah, and the analysis of this algorithm for time complexity, it is a linear time complexity because we are iterating on every element of the array, and the space complexity is order of k because we are using a remainder track linear data structure that requires k elements. That is the actually not k elements, k minus 1 elements, but still it's a big O of k as a big O notation. So these are the space and time complexity, and I think it should be clear to you, but if it is not, then you can obviously let me know in the comment section. I will try to make a video with more mathematical proof and explanation. I'm skipping that whole part because that's not a very interesting part for most of us, but if you want, I can do it because I have while solving this problem I had to figure that one out. So if you want it, I can do it, but it's fine for now. So yeah, thanks for watching and have a good day.